Assalamualaikum warahmatullahi wabarakatuh. I bid to my panel, Technologist Tsaminurrashid and Technologist Saliha binti Muhammadisa. Today, I will present my bachelor degree project and my title is Development of Sorting Machine Prototype by using Arduino. I will introduce myself first. My name is Muhammadisa. My metric number is B071710472 and my supervisor name is Madam Rosilawati binti Muhammad Noor.
For the introduction, there are three questions that we will explain about this system. First of all, what is resistor? Resistors are common elements of electrical networks and electronic circuits and important in electronic equipment. Resistors are also implemented within integrated circuits. There are a lot of types of resistors and value of resistors such as 4-band type and 5-band type, and for the value of the range differ from 10 ohm until 10 kilo ohm that usually used in lab experiment. What is sorting system? Sorting is any process of arranging items in some sequence or in different sets. It has two common distinct meanings such as ordering and categorizing. Sorting system is a system to sort goods to reduce human energy and time. Next, what is register sorting system? Basically, this system is a system that functions as to sort register in an orderly manner so that the register will sort based on the value of register. For the problem statement, this idea comes from the situation where students in the lab environment have difficulty to start their lab experiment because the register that they want to use for their lab experiments is not in the correct container. So that students have to take more time to check to measure the value of the register before they start their experiment because they have to make sure the value is correct, and this have caused the wastage of time, energy and labor. For the objective of this project, first, to develop register sorting machine prototype using Arduino. Second, to design sorting system for respective register by measuring the register value range. Third, to analyze the effectiveness of the proposed system for sorting purpose. For the scope of this system measures resistor 100 ohm, 1 kilo ohm, and 10 kilo ohm by using multimeter. This prototype also could measure one resistor at one time. The resistor leg must be straightened initially before enter the sorting system. The hardware for this system are direct current power window motor, stepper motor, servo motor, infrared sensor, and cone vibration motor. This system will develop using Arduino as the software. Sorting system start first with human power sorting system. Hand sorting is the simplest and most effective method of concentration. Humans use their sense of touch and sight to sort the goods. However, hand sorting becomes impractical, impossible, and too expensive due to decreasing of our gates and liberation size, changing the scale and economics of processing plants, as well as introducing new technology. So, this hand sorting system was abandoned. The next one is semi-automated. This system is where the sorting can be done, but still with the help of humans to place the goods manually before sort the system. Humans have to place the goods one by one to make sure that the system can sort the goods properly. Last but not least is the fully automated system. It is where the sorting is fully done by the machine. The advantage of fully automated system is the machine can sort a lot of goods at the same time without needed human to place the goods one by one. After going through past research journal, I noticed there are common use of controller for the sorting system. The most commonly used is Arduino, programmable logic controller, and Raspberry Pi. There are a lot of equipment that are used for the sorting system, such as camera, load cell, proximity sensor, and color sensor. Sometimes the researcher use camera to capture the equipment so that they can sort by using color or the shape or the size. And load cell usually used to sort the goods by their weight, and the proximity sensor usually used for inductive sensor or capacitive sensor. Inductive sensor used to detect whether the item is metallic or non-metallic, and the color sensor is used to sense the color of the object. The next part is the methodology. Methodology consists of three phases: phase 1, phase 2, and phase 3. Phase 1 is to develop resistor sorting machine prototype using Arduino. Phase 2, to design sorting system for respective resistor by measuring resistor value range. Phase 3, to analyze the effectiveness of the proposed system for sorting purpose. For phase 1, we start first with design the resistor sorting system part by part, and then try to assemble the part. If the part assembled nicely, then we proceed to the next one. But if not, we have to return to the design to make sure the part could connect nicely after they are assembled. Next, analyze the full assembly design. Then, after that, we create the 3D view and dimension drawing for all parts. For the mechanical design, this is my design, and it consists of silo, conveyor, DC motor, bin, stepper motor, multimeter, and circuit box. This system consists of 3 stations: feeding station, measuring station, and arranging station. For the station, it starts with feeding station. The resistor will be poured into the silo, and by using vibration, it will transfer the resistor to conveyor. After that, the conveyor will proceed to carry the resistor toward measuring station. The resistor will drop at measurement clamp, and servo motor will hold it to get accurate value and send to Arduino. After that, the Arduino will send the signal to stepper motor to rotate the correct bin below measurement station, and another servo motor will open to drop it correctly into the correct bin. For the second phase, we start with recognize and list out the equipment for the system, and then we compare the functionality of this item with a past project. If it cannot function as a past project, we recheck our list and make sure that the system is correct, and then after that, study the connection and create the circuit design. After that, we have to check the connection to make sure it is correct. If it is correct, we can proceed to the next phase. This is the circuit design of my sorting system. For the selected hardware, I choose Arduino Mega. This is the controller for this system. And then stepper motor, it to control the rotary table to place the correct bin of resistor. Power window motor to control the conveyor station and stop when infrared sensor detect resistor. Multimeter to measure the resistor value and send data to Arduino. I also choose infrared sensor. It detects the presence of resistor and sends signal to stop conveyor. For the servo motor, I need 2 servo. One servo hold the resistor to get accurate value, and another one will open the measure clamp to drop the resistor. I also choose con vibration motor because it will constantly vibrate to send resistor out from the silo. For the phase 3, it's about the development of the resistor. So, this system is start by the on condition of con vibrator and DC power window. After these two items have been on, we can feed the resistor into the silo. Then the resistor will move up from the silo until it reaches the conveyor. Then the conveyor will transfer the resistor toward the measurement station. After that, it will fall at the measurement station and detected by the sensor. When the sensor detects the presence of resistor, it will off the DC motor and on the servo one to hold the resistor so that multimeter can get the accurate value. After that, multimeter will send the value to Arduino to compare the data that have been programmed. The value of resistor that will be compared is 100 ohm, 1 kilo ohm, and 10 kilo ohm. If the resistor is 100 ohm, servo 1 will off and DC stepper motor will turn toward 0 degree, and servo 2 that hold the clamp of the resistor will on to make sure the resistor fall down toward below that already has been prepared a bin so that the resistor will fall into the correct bin. If the resistor is 1 kilo ohm, the DC stepper motor will turn 45 degree, and 10 kilo ohm, the DC stepper motor will turn 90 degree. If all three conditions is not met, which is the resistor is not in the range of 100 ohm, 1 kilo ohm, or 10 kilo ohm, it means the resistor is out of range and it will fall at the fourth bin, which is the DC stepper motor will turn toward 180 degree to make sure that the resistor of out of range will fall into the bin. If after that, if the stop button is not pushed, this system will go toward upward again to make sure it in a loop position until the stop button is pushed. Then the system will finish. This is the enlargement image of phase 3 flowchart to make sure that we can read more clearly about the process of the program. For the preliminary result, I have two results. The first one is time taken to measure the resistor, and the next one is the average value of chosen resistor measurement. Time taken to measure, I have test on field to measure the resistor manually, and the time taken to measure one resistor, it takes about 2.5 seconds, and for two resistor, it takes about 5 seconds, and for three resistor, it takes about 7.5 seconds. So this prototype expected to sort the resistor in range of less than 2.5 seconds per pieces. For the average value of chosen resistor, this is the table. I have measured 10 pieces of each type of resistor, and this is the value for 100 ohm. This is the value for 1 kilo ohm, and this is the value for 10 kilo ohm. This is the Gantt chart for my progress doing this PSM1, and I have managed to follow all the progress. Although there are some problems such as COVID-19, I managed to finish my PSM1 according to this timeline. For the conclusion, this project is designed to help students and lab assistants to sort resistor more easily and reduce wastage of time, energy, human error, and labor. After that, this system is to provide continuous sorting for 100 ohm, 1 kilo ohm, and 10 kilo ohm resistor, including out-of-range resistor. This system will also provide auto-feed resistor into conveyor to reduce time. And this is the reference of my presentation.
That's all for my presentation. I hope that you can understand more about my project after my presentation. Thank you for your time.